Hello, good evening all. Can you all hear me?
Yes, ma'am. Good evening.
Yes, good evening all. So welcome to Starts to this is the first live session for you. Okay, so shall we start now?
Yes, ma'am.
Yes, ma'am.
Okay. So first of all, have you all gone through week 1?
Yes, ma'am.
Okay. So what all topics you are finding difficult there?
I haven't gone to the contents of week 1 yet.
Okay. You haven't gone through the content. Anybody else?
Ma'am, concept-wise, it is easily we are grasping it, but sometimes when we get questions, we get confused with the question sometimes, and while solving it.
Yes, ma'am. The question is really confusing.
Yeah, ma'am.
Okay.
Difficult to apply actually.
All right. So we'll go through the questions. Okay.
Okay, ma'am.
Yes, ma'am, because sometimes we get confused, like with cards or balls, if it is replacing it and non-replacing it. Sometimes the answers is calculating with non-replacement, and sometimes the same base question going it without replacement.
Okay. Fine.
Ma'am, why there is week 0? There is too many lecture we have to complete in the
Okay.
one.
So week 0 is supposed to be like revision of statistics 1. So like you must have seen like all the content that is there in week 0 has been covered in stats 1, right? Except
Yes,
some distributions part.
yes, ma'am. Binomial distribution and Poisson distribution. These things.
Binomial distribution has been covered in stats 1 as
Yeah, Poisson distribution.
so Poisson, geometric, all this negative binomial, all this you haven't seen in stats 1, right?
Yes, ma'am.
So you must have received week 0 content before getting the week 1 content, right? No.
No, ma'am.
No,
We got
ma'am.
all them together.
We got it together, ma'am, and
Yes,
that's why we didn't get enough time to refresh actually.
And I think
week
tomorrow
0
and today or tomorrow, the week 2 is also going to release.
yes. So week 0 was released some last Tuesday, if I'm not wrong.
Tuesday.
No, I couldn't see it on my portal actually.
No, ma'am.
Last Sunday it was released, all the content.
Yeah, exactly.
On 29 April.
Okay, it's fine. So can you tell so week 0 content, most of it, since it is part of stats 1, so can you tell me like what all topics in week 0 that you want to have a session on?
No, ma'am, we don't want a session on like week 0, but I was just asking that why it is week 0 and 1 together. It becomes a lengthy week. Because
Okay, so
we have almost
you're not supposed to
lectures.
go from week 0. You're not supposed to go through week 0, but some extra activities, if you can you mute yourself?
Yes.
So you must have okay, somebody else is there. So extra activity part you must have seen, right? So in week 0 part 1, week 0 part 2, like first 2 extra activity that you're going to do is from those lectures. So you must have received the time stamp also, like what all part you have to see. And why like, but going through the distribution is important if you are not if you don't know what binomial random variable is, what a Poisson random variable is, what a geometric random variable is. So going through those distribution is important for you. because as you move to the other weeks, like week 1, week 2, as you move across the different weeks, like these distribution will come again and again. So it is important that you understand those distributions also. So just the distribution part alone you can study. And if you have any difficulty, so we are also going to give you a note on week 0. So you just can go through that note, the distribution parts alone. So I think that
That will be
will
really
be,
good, ma'am.
yeah.
And suppose, sorry to interrupt.
Yeah.
Ma'am, I was saying that if someone is unable to go through all the lectures of week 0, the note which you are talking would be enough to,
Yeah, enough
summarize the
to
week 0.
Yeah, yes.
Week 0, right?
It is more than sufficient. Yeah.
Okay.
Hi, sorry to interrupt. I just joined right now.
Yeah.
Something I missed important.
No, nothing so important. So what I was telling is like, if week 0, you are not supposed to go through everything. If it's just the revision of week 0, so just the distribution part alone, like identifying the binomial distribution, Poisson distribution, geometric distribution. If you can study just these part alone, then it will be useful. And also we are going to provide you the notes for week 0. So you can just take a quick look on different distributions. So that will really helpful for you. So it is
Okay.
not yet uploaded, but it will be uploaded in a week or so.
In which section it will be uploaded?
It hasn't been uploaded yet. It will be informed.
Okay,
You will be
okay,
informed.
thanks. Okay.
Excuse me.
Yes.
Ma'am,
Okay. Yeah, Devanshi, please go on.
Yes, ma'am. Ma'am, could you please throw some light on extra activity thing that we have to do through Google Sites?
Okay, so the first extra activity that you are going that you have seen is like you have to create a Google website, Google site, and there you have to create your portfolio. So that is your first assignment, right? And the second extra activity part is like you have to collect some data set and give some insight on that data set. So these are very easy activities. So extra activities just for the bonus marks per se, like these are the extra bonus that you are going to get apart from your regular 100 marks, right? So it is just for your own interest. Like, can you mute yourself? Who is there? Yeah, so it is just for like as you keep on doing extra activities, you will go through the practical aspect of where you're going to use it and all, and it is something that is optional. It all depends on your interest. So whatever marks you will score in extra activity, that is going to get added in your total marks that you have obtained so far in stats 2 course. So you will get some 5-6 activities throughout this term, and I hope you will enjoy. So I will encourage all of you to just participate in it.
And out of that 6 activities, we were told that some best 4 activities will be chosen. Like
that is right.
Activities,
yes,
the best 4 will be.
Yes, that is right. It all depends on what all activities you can do.
Oh.
So there will be
as today is the first day of our live session, so
yeah,
just can you brief us something about like how are we going to plan live sessions, like how many sessions will be there per week, and what will be our approach, right?
So the session, so one session will be a regular solve with a session, right? And that will happen every Tuesday. And there will be 2 more sessions. So one is this Friday, that is fixed, and other session will be on demand session. So like how it will happen, all this information will be provided to you.
But on demand is not clear, ma'am. Like like when calendar is fixed, then we are well aware that when live session is going to happen, so we can plan our schedule accordingly, right? This on demand, so all of us converge on some day, right?
Okay, yeah. So like what happens is, like if let's say we are getting there is some topic where students have a lot of problems and understanding that. So in those special live session, we can discuss that topics in detail.
I see.
My point is how when we are going to finalize that on-demand session, how we will finalize a particular day in a week,
So it is going to be Sunday every day, like every week it is going to be a Sunday.
So we can fix a normal live sessions on every Sunday. So there will be clarity that every week we have 3 live sessions. So accordingly we can prepare, and if some doubts are there, we can ask questions. This is just a suggestion. I cannot instruct. It's a
Right.
It's your prerogative. How you want to plan it, but that's a suggestion that we can have 3 live sessions normally. Like in stats one also we had 3 sessions, right?
Yeah.
So stat is more involved and more critical.
No. Every week you are going to have 3 live session. That is for sure. Every week it is going to be 3 live session. And one live session.
Live sessions on Sunday also.
Yes.
Sunday?
Yes. You have a live session this Sunday.
Calendar is not updated so far.
On Sunday there is a session.
I think it is updated.
Okay, let me check again now, please.
It should be updated. So every week you are going to have 3 live session, and 1 live session will definitely on weekends.
Yeah, it's updated.
And then one more input which I am facing problem. Maybe that I am odd man out. Like all the lectures are one-way communication kind of thing, right? Like a professor is teaching over video lectures, and I'm just listening, and whatever doubts are coming to my mind. So what I will request that if we can also allocate some time for doubt clarification also. Otherwise, what happens normally we jump directly into problems and concepts on, so then take a back seat.
Okay.
And when we appear in the monthly quiz or the final exam, then questions are purely concept based, right? It's not like that we have solved 10 problems, so we are going to get 4 problems out of those 10 problems. So this is my personal experience that we should give equally importance to concepts also.
Yes, definitely. The first, your concept should be very clear. Your concept should be very clear. So like if you gain the good command on the concepts, then the problems are not so difficult, right?
Sorry to interrupt. What we will be doing in today's session?
So today's session we are going to see the activities activity questions and some other doubts if you have.
Okay.
Ma'am, I had doubt in that extra activity, ma'am, if I can ask you.
Okay, yeah, please go.
Ma'am, on that extra activity part 2, we are being told to collect some data from a source, and that should contain some 100 rows and 5 columns, something like that, and we have to explain that in detail, and we have also to paste that link. Ma'am, I wanted to know, is there any information, can you give us a hint on from where we can get this information, like any source you could tell or any hint you could tell?
Okay, so the data you can get from anywhere you want, or you can just cook up some data. That's not the issue. So whatever data you collect, either from online source or some article somewhere, so you collect the data, and the data should have 100 rows and 5 columns. And whatever data you have collected, you just have to give a brief explanation, what it is about and what you have collected, and so also.
Okay,
but it is not much.
Okay, but ma'am, is there any means we can collect it from online source, or
you can collect yeah,
personal source also, right?
Yeah, you can collect. It just for you to okay. So it has told to avoid Kaggle.
Someone is asking that can we get data from Kaggle? So I replied that sir suggested not to refer Kaggle.
Okay.
Ma'am, can I ask regarding the code shift competitions?
Code shift competition. Okay, I'm not very aware of it. I don't know what exactly it is. So maybe you can ask in some other PDA, right?
Okay.
It's for Python.
Okay, it's Python. So you can ask in the Python live session.
Okay, sorry.
And talking about the data sets, if
Can you please give any source or any hint? Where
Can I answer this?
Yes, you can answer it.
May I
Who's that?
give answer? You can collect your personal data like Google Feed, your browser
I'm not
history from Google Takeout.
Can you mute?
I'm not
Can you
able
mute
to
yourself?
understand.
Can you please mute all?
Who's there? Can hear a lot of noise.
Excuse me, ma'am. Ma'am, will
Okay. Now tell me. Who
Yeah,
is
can
there?
I
Yes.
just wanted to give you an insight of the data. Like there's a Google data set search engine from Google itself. So wherever, like in that, I have shared the link as well on the chat. So even if you write a particular topic, like if you want to explore the data of COVID, so there will be a lot of sites it will give you where you can collect data. It will give you a number of sites from all over the web. So that's how you can just explore the data. That's a
This
suggestion.
takeout.google.com you have shared, which? This one?
It's a Google dataset search engine. I will share it once again.
Yes.
The dataset search engine from Google itself. So
Oh, I see.
you can explore it. You can just type the name of the dataset you want to explore, and a lot of pages will be there from what except Kaggle, like as sir informed. You can explore the other sites as well.
Like I can search on any topic.
Yeah.
On
You can
any
just type the
topic.
name of the topic, and the dataset will be there of that particular topic, which is available all throughout the web.
Oh, I mean, okay. Yes.
And we can take that use that data on Excel sheet.
We have to.
Yeah.
So that we have to do by ourselves. I mean, we have to.
Okay, so you can discuss about it on the
Respected
Google
Nikita
chat.
ma'am, I have one
Discuss
last
about.
thought, ma'am.
Okay.
Respected Nikita ma'am, actually they are discussing about a lot of platforms. Ma'am, actually I'm interested in stock market. Therefore, shall I take the data from NSE and National Stock Exchange or Bombay Stock Exchange for making this kind of project, or is it necessary to take a data from Kaggle only? Thank you, ma'am. That's my only question.
Okay, so you can take the data from anywhere you want, you are interested in. So it is all right.
Ma'am, I have a one question. I required a help regarding how to convert. For example, sir has told that a YML format. So in that case, if I am getting some different format, so how to convert it into XML or through Python programming, or how we can approach to that. So and how we can use this NumPy concept. So
Okay, there was one live session that was conducted last Saturday. So you can go through that live session. I think the recording is available. This all has been discussed in that live session. So if possible, please go and watch.
Yeah, sure, ma'am. Thank you.
Yeah.
Ma'am, can we get
the recording is not available, madam?
Recording is not available.
No.
It is on YouTube, right?
No, YouTube also not available, madam.
It's available. It's available. I'm sharing the link.
Yeah, please share the link on the chat box. Yeah.
Ma'am, ma'am, can we get the detailed solution of activities question of week 0?
No, you will not get the solution of activity question. Please try it on your own. Like it's all the basic starts.
Ma'am, some of the questions are quite difficult for understanding the concepts or the logic or getting the answer.
Yeah. So if you have a doubt in there, you can always post it on Discourse. There are many students who keep answering the questions, or if you can also tag some of us instructors, it will help you out.
Ma'am, can we for the week 0 assignment that we have to create data that we have to create our own, or we can collect it from somewhere else like internet?
You can create your own data also. That is also fine.
Or we can collect from internet also.
Yes. So this has been discussed now a lot of time here. So
and are we going to get some tutorial videos like stats one?
Sorry.
Are we going to get some tutorial videos like stats one? like stats on the distribution?
Stats. Okay, solution tutorial. I mean,
Yes, or some,
video tutorial.
yes, video tutorials. Yes.
Yeah. So for few weeks, it is for first week it is not uploaded, right? Yeah. So it will get uploaded soon. I will upload.
Tutorial videos are there.
Yeah, I will upload this.
Those are not tutorial videos, those are simple questions. Just
so there are tutorial problems there. You have so many problems in tutorials and you have to just go and try to solve it. Solutions are also available. So like, don't try to see the solution first, try to do it on your own. But if you have any doubt, just check the solution and try to understand. If you still couldn't understand, just you can ask any of us. Okay. Discourse link is not working for somebody. Okay, I'm not sure why is it not working. Okay, so for many of you, the discourse is not working. Did you get the invite?
Yeah, ma'am.
Yes, ma'am. We got the invite. They also gave a form to put the issue. I have done that, but still it's not working for me.
Yeah, like
Okay.
Yes,
so
madam,
you
lot
can mail to the support team, and I will also convey this.
Yeah,
to
I have
the
mailed them.
mail.
They have also shared the Google form. I have submitted them, but still now it's not working.
Maybe it will work. So if many of you have
Respected
any issue,
Nikita ma'am, it start working, ma'am. Today after 1 p.m. my discourse forum start working. I think
it
take
will work.
time.
It will
After
work.
an hour, it's available for all the stats students.
Yes, it's available.
Okay.
Okay.
So, okay, can we start now? Is
yes,
all
yes,
everything
Yes, ma'am.
done? Okay. So,
Yes.
I will share my screen. You can let me know what all questions you have difficulties in. So I will write it down and we can discuss just those problems here.
Activity question, right? Yeah, ma'am.
Yeah. Yes, activity questions.
Yes.
You can go one by one.
Okay. Should I raise my hand, sir? Or
Yeah, you can raise your hand. I will ask. Manan Vasudev.
yes, ma'am.
Yeah.
Ma'am, I had doubt in this activity question 1.4.
Okay.
It's question number 4, ma'am.
Question number 4. Okay. Anything else?
And also, ma'am, question 6, 4 and
Alright.
6 of the same activity.
Okay. Sandhya.
Hello.
Yes. Hi, Sandhya.
Yeah, hi, Nikita. Is it possible for you to briefly explain the distributions, way to use applications, if possible?
Distributions. Okay.
Yeah.
So distributions part we will discuss on Sunday. Okay. So Sunday we'll focus on all the distributions.
Okay.
Today we can concentrate on just week 1.
Yes.
Can I answer?
Yes, ma'am, please.
Yeah.
In fourth question, can I answer?
Ashish.
Yes, ma'am.
Yeah. Tell me.
Ma'am, I have a query. This is for week 1 and tutorial questions in tutorial.
Tutorial? Which tutorial?
Ma'am, the first tutorial, it is from question 13.
Okay.
So I need to understand that statement, and then from tutorial 2, it is the question 19th.
Okay. Okay. Rakesh.
Madam, I have some different question. Like generally, for there's one question in activity thing. So like, for example, for a multiple answer question, the MCQ, if there's only one multiple answer, like we can find the probability 1/4. If there's a chances of having multiple right answer, the probability would be 1/C1 plus that we calculate it. Okay. If you are allowed to having your partial marking, how would you find the your probability of getting a certain marks? This kind of question I doubt. We can discuss it later on.
Okay.
Like, so my doubt is on that part only.
Okay, okay, fine. Nachiket.
Ma'am, actually, I had a doubt in week 0.28.
Week 0.28.
Question 1 and 3.
Dripto. Okay, so we'll start the solution then.
Yeah, ma'am, please.
Yeah. So AQ 1.4. Okay, so first we'll start with activity 1.4. Okay.
Yes.
Yeah.
No, it's not visible.
Yeah, wait. So okay, so in this problem, it says the number of customers arriving at a shopping center in a 1 hour interval is Poisson random variable. So there you have a random variable n, and that is what does it represent? It represents the number of customers arriving at a shopping center. Arriving at a shopping center in 1 hour interval. Now it is given that this random variable n is a Poisson random variable. Okay. It is given by Poisson random variable. So what is 20 here?
It's lambda.
It's lambda. Okay. Now what you have to assume is, it says assume that the probability of customer making a purchase is 0.4. Now whatever, like whoever is coming at the shopping center, so the probability that any customer will buy a product, so probability of purchasing a product is given by 0.4, and the choice of purchase of customers are independent. Now you have another random variable x that represent number of customers who are making a purchase, right? Number of customers making a purchase. So, okay. So the first problem that comes here is like, given, let's say I have n customers, n equal n customer are coming to the shopping center. Now, out of n customers, how many are going, let's say n customers are coming in. So, and X represent the number of customers out of n who are making the purchase. So what does this random variable will represent? X given n, like what kind of distribution it is? Like n customers are coming in and X, total number of X customers are making a purchase.
Binomial.
Binomial.
It is binomial, right? So this represent your binomial random variable, right? And what are the parameters of binomial random variable?
N comma 0.4.
So in this n comma p, right? So probability of making a purchase is given by 0.4. So I will just write this is 0.4. Okay, so the next question that come here is like, if you have n given to be a Poisson random variable and you know that X given n equals n is a binomial distribution with the parameters n comma p. So how will you write the joint distribution of n and X? So if I have to write, so you have a random variable n, you have a random variable X, right? Now we want to write the joint distribution of n and X. Okay. So let's say this is n and this is X equal k. So what can I write this to be?
For the given situation, we have a formula for that. So we'll multiply
Yes.
formula for binomial probability for I successes, which we had done in the previous semester, and we'll multiply it with this thing, the other formula. I'm not able to recall it.
Okay.
Ma'am, NCK, I think NCK, P power K, 1 minus
so
P.
how do you write
K.
the joint distribution? Like in which form do you write the joint distribution to be?
In the form of table.
So joint can be written as a product of conditional times marginal, right?
Yes.
Right. So the conditional here we have, like we know the distribution of the conditional here, that is X given n. So we can write this as f of X given n equals n of k times the marginal, and marginal here is going to be f n of n, right? So this we know that this X given n equal n, this is this represents a binomial distribution, fine. So how do you write this? Like what will the probability distribution? We know that X given n equal n, this is binomial n comma 0.4, right? So if I have to write, let's say I want to write if X given n equal n of k. So what is the distribution here? We know that this is a binomial distribution. How will you write it?
N choose k.
And choose k.
Okay.
To the power
Times
power k and 1 minus
probability raised to power k.
The probability of success raised to the power k into 1 minus
to the
p to
power
power
yes,
n minus k.
Yes, that is right. So in this case, p is 0.4. So I can write 0.4 to the power k and 0.6 to the power
0.6 power n minus
k.
N minus k. So, and what is fn of n? What is your random variable n represent? It is a Poisson random variable, right? And what is the distribution function of a Poisson random variable?
E to the power minus
E to the
lambda
power minus
into
lambda
e to the power
to lambda to the power k by k factorial.
Yes. So if you have can you mute yourself? Please mute. Yeah. So if you have a Poisson random variable, so let's say if you have a random variable that is a Poisson random variable with the parameter lambda, then the distribution function of x is given by e to the power minus lambda to the power x upon x factorial. So the same thing we will use here for fn of n. So in this case, it will become e to the power minus lambda to the power n upon n factorial. Yeah. So now we just have to multiply these two terms, correct? So if you multiply these two, you will get n choose k 0.4 to the power k 0.6 to the power n minus k e to the power minus lambda to the power n upon n factorial. So you can also like solve this n choose k and you can get a simpler term, I think, little. So right, so till here it is fine. Now the next part, what does it say is you have to find the distribution of x.
Yes.
So we know what is the distribution of n. N is Poisson lambda. We know the distribution of x given n, that is binomial n comma 0.4. Now we want to find the distribution of x. So what is the distribution of x? Okay. So you have two random variables n and x. So if you have to find the marginal of a random variable, right? So how do you find the marginal of a random variable? If you know the joint distribution, we also know the joint distribution. Fxn we know, right? We just found. This also we know. So if you have to find the marginal, how do you find the marginal?
We just sum over the columns and rows and for each variable, and that gives us the marginal. Suppose fx of
okay.
So
yeah,
if the table is
let's
given,
say if you have a random variable x, you have a random variable y, and let's say x is taking the value 1, 2, 3, y is taking the value, let's say 0, 0 and 1, and you have some joint distribution, let's say a, b, c, d, e, f. Okay. So first thing is all of this should sum to 1. A, B, C, A plus B plus C up to F should sum up to 1. And if I have to find the marginal of x, so if I have to find, let's say, fx of 1, what is it?
it will be a plus d.
A plus
D.
D. If I have to find fy of 0,
A plus
A plus B plus C. So what we are doing is like we are just, so what is A, B, C? These are the joint distribution of the random variable x, y at the point. So A is the joint distribution of x, y at 0.1, 0. B is the joint distribution of x, y at 0.2, 0. So we are just summing it over the joint distribution for the particular x or y, right? So let's say if I had to find the joint distribution of x, marginal of x at fx of 1. So what we did is we sum it over like all the y, that is we sum it over the y, right? So a plus d. If we have to find the marginal of y at 0, then we will sum it over the x values. So similarly, if I have the joint distribution of the two random variable x and n, and if we have to find the marginal of x, what we will do?
We will sum up that entry. I mean, sigma k.
Sigma, sorry, can you repeat?
Sigma and that k
Sigma k.
Mhm.
Like what are you summing? I mean, what are you going to add? So like if we had like this is the joint distribution of x and y, right?
X is equal to 0 and fxy.
Fxy.
X here k, in place of k we will write x is equal to 0 till 3.
There are a lot of noise from your side.
In the place of k we will write x.
Okay.
X is equal to 1
Okay.
to 3.
So you're talking about this
Yeah.
table.
Yes,
Okay.
ma'am.
No, I was asking for this
General term.
no, not the general term. I was asking for the random variable for the joint distribution of x and n. So I wanted for that. Okay, let's say okay, first let's talk about this table. So if I had to find fx of 1, so what we did, we sum it over, we did the sum of fx of y over y, right? So if we have to find the marginal of x, we sum it over the y value, y belonging to t of y, right?
Yeah.
And if we have to find the marginal of y, let's say I want to find fy of y, so we are summing the joint distribution of fx of
Over
y
x.
over x. So x is taking the
Yes, ma'am.
value 1, 2, 3, right? So x belonging to t of x.
T of
Now,
x.
right? So this is what we are doing if we are finding the marginal.
Okay.
Now, here in this case, we have two random variables, n and x, and we know the joint distribution of x and n. Okay. And we have to find the marginal of x. So what will you do?
Summation over the range of n.
Yes, summation of fx of n over the range of n.
Yeah.
Right? So now we have to simplify this term. Sorry. So we want to simplify. My screen is visible, right?
Yes, ma'am.
Okay.
It's not exactly, it's blank screen right now. Is that
Yeah,
it?
yeah, it's blank screen right now.
No, it is.
Okay, so what we want is we want to find fx of k, and this we are going to find by summing it over n value, right? Like whatever the range of n is. Okay. So what is fnx, fn of x we found? It was n choose k, like e to the power minus lambda, lambda to the power n upon n factorial, n choose k, 0.4 to the power k, and 0.6 to the power
and minus
n
k.
minus k. This is what we had, and we are going to sum it over n. Now, okay, so in this case, see, your k cannot be greater than n.
Yes, true.
Right? So in that case, so if k cannot be greater than n, so we will neglect those terms, right?
Yes.
So we will just go through. So we'll just take your n from k success to infinity, because your n is what? N is Poisson random variable. And the range of a Poisson random variable is from 0, 1, it goes till infinity.
Yes.
So the distribution part, if it is not clear to more of you, so distribution alone we'll see on the Sunday session. Okay. So for now, just just keep this in mind that if you have a Poisson random variable, the distribution function is given by e to the power minus lambda to the power x upon x factorial, and its range is from 0 to infinity. So we have to sum it over from n equal k to infinity. So we'll just do it here. Now we can solve it.
Sorry to interrupt, but I would like to ask a simple question here.
Yeah.
Why are we doing it from k to infinity? Because less than equal to k is equal to 1, or why is that?
Okay, so less than, if you do the less than, if n is less than k, so what will happen is your fx of k, right? This will become 0.
Which one are you pointing to, madam?
Okay, just put k equal 0 here.
If n is greater than k, how will you choose k from n? If k is greater than n, how will you choose k from n?
Yeah, right.
That is why it is 0.
Yes, it is.
Yeah.
Ma'am, I had a doubt. So why can't the range of a t given x, x given n equal to n, why can't the range start from 0?
X given n, you're saying x given n?
Yeah, x given n equal to n, small n.
Okay.
Why can't the range of this start from 0?
The range will start from 0. This is what? This is a binomial distribution, right? And it is binomial NP. So if you have n trials, either you can have a 0 success or 1 success, and it can go maximum till n success.
Oh, okay, got it.
This is x given n, you can have a range from 0. And
sorry, but I am not really clear about why we are not picking for values less than k. You said it is going to 0, but
okay. So if you have, if n customers are coming in, how can more than n customer buy a product?
True.
True.
Okay.
Yeah.
So that is why can you mute yourself or something?
Me?
Yeah. Yeah. So you have n customers coming in, right?
Correct.
And number of like customers who can buy a product can always be less than n.
Yes.
So your k can never be greater than n, right?
Correct.
So that is why your n should be so n should be greater than k, greater than or equal to k.
Sorry, maybe I'll ask you from the equation that you've written above, 0.6 power n minus 0.6 power n minus k. If
0.6 to the power n minus k, right?
If k is greater than n, then the power of 0.6 goes negative.
Yes, it goes negative.
Then the entire thing goes negative. I mean, it goes to the denominator.
Yeah, it will go to the denominator. You can also look over here, right? Like this n choose k.
Yeah, and if k is greater than n, then I'm having
it is
10c
like
100.
it doesn't make sense, right? You have like you have n and you are choosing more than n.
It will be 0.
K can't be greater than n.
So it will be 0.
It will be 0, right?
So that is why n should be greater than equal to k.
Okay.
And n, we know that it is a Poisson random variable. So the range of n will go till infinity.
Okay.
Okay.
Yeah, n should be greater than k that part is clear, but you had in the left side screen you have written as k is greater than n. That is the one that actually threw me off.
This is not equal to n, actually.
No, this for this part, this is going to be 0. That's what I had written here. Like I didn't write it complete here. Okay. I just erase it.
Okay.
Yeah. So, yeah. So once we simplify, we have this expression now, and we have to simplify this. Right? So you have n varying from k to infinity. And you have e to the power minus lambda, lambda to the power n upon n factorial. Just n choose k, we can write it as what? It is going to be n factorial upon k factorial, n minus k factorial. Right? And this part we can just leave it here. So once you simplify it, e to the power minus lambda and k factorial, we can keep it out because they are constant term. So e to the power minus lambda and k factorial, we pull it outside. And inside we are going to have lambda to the power n, 0.4 to the power k, 0.6 to the power n, and n minus k.
N minus k upon.
So if you simplify everything, you will get it in the form of, again, Poisson random variable. So, okay, just let me try this. So lambda to the power n minus okay, this part also you can take it out, 0.4 to the power k, because it is a constant term, and 0.6 to the power k also you can, okay, just don't put it out. So lambda to the power n, 0.6 to the power n minus k on n minus k factorial. Okay, so here you can also add and subtract plus minus k. So if I subtract n minus k here, so you'll have to add plus k and you will get lambda to the power k out. Okay, so now everything you have in the form of n minus k, and k is varying from n is varying from k to infinity. Can you solve this expression?
That's where every student gets
Okay, okay. Fine. Okay, just we'll clear server part. We can do this.
So basically, when you multiply lambda into 0.6, that term will become like summation of a certain thing to infinity, lambda to the power of x, like by x factorial, it's e to power x. So then bring it out and multiply. So basically, you'll get it in terms of Poisson ratio itself when you solve completely.
Yeah, you will get something of the Poisson form. So basically,
I think it'll be easier if you do the problem. So in that way, like there was like 20 into 0.6, so you'll be easy to do. Like e power 12, you'll get, bring it out. I think it'll be easier for you to solve with that numbers itself. You'll get that Poisson distribution in the end.
So
20 into 0.6, you are saying. Answer is coming.
Yeah. So basically, you basically put in term place lambda, we have 20, and solve it. You can easily solve it. here it's like a little bit confusing, right? Just put lambda in 20. What was in the question?
Yeah, lambda is
Then
given
lambda
to
is
be
20.
20 here. Right.
0.4 is
See,
the probability, and if we
see,
multiply both,
basically what I'm telling is whatever is outside, right? It's e power 20 into if you start from first, whatever you can take the common things, right? With the numerator k, whatever the constant is, that is e power minus 20 into 0.4 to the power of k into 20 to the power of k. By k factorial, you can take it outside. Whatever remains inside will be summation from k to n, 20 to the power of n minus k by n minus k factorial into 0.6 to the power of n minus k. So 20 into 0.6 will be 12 inside. 12 to the power of n minus k by n minus factorial summation is e power minus e power 12. Outside you already have e power minus 20. Sorry, I'm going too fast because I can't solve it in the board. Basically what you'll get in the end is e power minus 8, 8 power k by k factorial, which is nothing but Poisson distribution of 8. And basically if you put lambda to the power of lambda as 20 here, you'll get it right away. I'm sorry if there was a distribution.
Okay, so who is there?
basically the distribution of
Manan, right?
Yeah,
it's Rajan. So put one thing.
So just try to solve this. So okay, we have to start from n equal k, right? N should start from k. So put k to be 0 here. So it will become 1. Again k n equal k, it will become 0. So it is going to be 1. First term is going to be 1.
No, like right away whatever you have, right? You have that step is proper. Just put that lambda equals to 20, you will get it right away. Whatever you want to tell. It'll get solved by itself. You'll get Poisson distribution, Poisson of 8.
Poisson of 8. That's 20 into 0.4, right? I mean, the lambda into, I mean,
if you want,
no,
I can put a snippet or something what I solved. So see, basically in that step, whatever ma'am has been doing, right? The first step below itself, there put lambda equals to 20. You'll have basically 20 to the power of k into 0.4 to the power of k into e power of minus 20 by k factorial, right? So basically what happens, 20 into 0.4 outside you'll have 20 into 0.4 is 8 power of k by k factorial into e power of minus 20 summation of k to infinity 20 to the power of inside will be n minus k there in the previous step.
Correct.
20 to the power of n minus k into 0.6 to the power of n minus k, which is nothing but 20 into 0.6. Yeah, 12 power n minus k by n minus k factorial. This whole summation thing is nothing but e to the power of 12. That is the general formula. Yeah.
Okay.
Now you have e power of 12. That whole summation would replaced by e power of 12, and outside you have e power of 20. E power of 20 into e power of minus 20 into e power of 12. Which is nothing but e power of minus 8. So in the end, what is remaining is e power of minus 8 into e power minus 8 into 8 to the power of k by k factorial, which is nothing but Poisson distribution of 8.
This is actually whole proof of what ma'am was trying to tell and what the distribution.
Yeah.
Okay.
So I mean here there's some confusion, so I thought of stepping in.
Instead,
Can
we can, ma'am, can we use this formula? I mean, which you have written here, Poisson of lambda into p.
So this is what you will get at the end once you
At the
solve
end.
it. Yeah,
Okay.
like for any p, like whatever p is, and for any lambda, like this
to calculate
fx
distribution
of
of
k,
x.
you are going to get Poisson lambda p
Poisson
at the
lambda
end if you solve it. Yeah.
So end product will be this Poisson lambda into p.
Yes. So just try to complete the proof. Okay. So just now Srizan has also given you steps to how to do it. So just try it out.
Sure.
You don't have to remember this. I mean once
proof
you
we
do
don't
it
have to
once,
remember,
it
but
will be
let's-
it will be clear. Yeah.
Yes, ma'am.
So that's how it comes out to be Poisson 8.
Poisson
Because
of
lambda is 20 and it is 0.4.
20 into 0.4. Yeah.
Yeah.
Yeah. Sure. Thank you, ma'am.
Okay.
Who was the gentleman who was actually explaining this?
Srizan. It was Srizan's, I think. Yeah.
Sajan.
Sajan.
Can you share your solution?
Sure.
Yeah, please.
Yeah, I have
Share it.
I've written it on page. I'm not sure you can understand.
You can.
Let
I
me
think
say-
you can post it on Discourse.
Discourse.
Yeah.
That will be good.
Yeah.
Yeah, sure. Let me try.
Tag ma'am also.
Just mention the which
Topic.
activity question it is and week.
Yes.
Yeah,
Okay.
sure.
Yeah. Thanks, Rajan. Yeah.
And ma'am, I was also.
Which question was it? I'm sorry.
It was question number 4.
Question 4.
AQ 1.4.
Question 4.
Question 4.
Question number 4.
1.4 question 4, right?
Yeah.
Yeah.
Yes.
You can name the
Okay.
thread means AQ 1.4 question 4 and
It's
add your
okay. It's just
solution.
1.4 question 4, right? That's all.
Yeah.
Yes.
Yeah.
Okay, fine. Yeah, I'll put it there, or I'll just put it in this chat itself. Let me see.
This
Yeah.
course here.
Yeah, sure.
Okay. Ma'am, one last question, question 6.
Yeah, question number 6. Okay, so in this problem, you have a random variable x that is uniform in 1, 2. Can you mute yourself? There is noise. Okay, so AQ 1.4, question number 6.
Yes.
So the problem says, who's there? Okay, it says your random variable x is uniform in 1, 2. Okay, and you have another random variable y that denotes number of aces obtained from a deck of well shuffled 52 cards in X draws. So number of aces in X draws. And this is with replacement.
Yes.
Okay. So the first question over here is like, what is this y given x represent? So you have a random variable x that is uniform in 1, 2. So the probability of this is going to be 1/2, and the probability of this is going to be 1/2. Now y denotes number of faces in X draws. So X draws means for 1 draw or 2 draw.
2 draw.
Right. So if the number of draw is 1, how many aces can you obtain?
0 and 1.
0 and 1. If number of draws is 2, you can have 0, 1, 2. And what kind of distribution it is? Y given x.
And it's uniform distribution.
Y given x is uniform.
Yes, sir.
Binomial?
It is binomial. So y given x, why is it binomial? Because okay, you have x can be 1 or 2, right? So in one draw, y represent number of aces that you can have in one draw. Right? So you can have either 0 draw or 0 aces
0 ace or 1
ace, right? If you have 2 draws, you can have either 0 ace or 1 ace or 2 aces. Right? So this represents your binomial distribution with the parameter k and p. Okay.
K here is the number of
P here is it is going to be 1/13, right? Because in
okay,
one draw, the probability of getting an ace is 1/13.
Okay, 4/52.
Now you have to find the joint distribution of x and y.
Yes.
So what all distribution is known to us here? So first thing is we know what is the distribution of x. It is uniform in 1, 2. We know the distribution of y given x, and it is binomial, right? So if I have to find the joint distribution of xy, how are you going to do it?
That will be marginal into condition.
Right. So if I have to find fxy, so this is going to be marginal times conditional. So I can write fy of x times fx of x. Right? So what all values your x can take? I'm making the table here.
Yes.
So what all values for x is possible?
1,
1, comma 2. What all values for y is possible?
0, 1.
0, 1.
0, 1. What about 2?
Yeah, it can take.
2 is possible, right?
Yes, possible.
Yeah. So, okay. In here, what it says is you have one row. You have one row, and number of faces that you obtained is 0. Right?
Yeah.
So basically, you have to find f xy. What is x here? X is 1, y is 0. So this is f y given x equal 1 of 0. Oh, sorry, here it was y. And fx of 1. Fx of 1 is
1 by 2.
1 by 2. And what is this distribution? This is going to be binomial. What is n?
1.
N is 1, right? And what is p?
1 by 13.
1 by 13.
1 by 13. So what do you mean by y given x equal 1 of 0? It means out of n trials, you have 0 successes.
12 by 13.
0 successes, right? So it is going to be 12 by 13 times 1 by 2.
6 by 13.
So it is going to be 6 by 13.
Ma'am, 1 minute. This 12 by 13, how, ma'am? Yeah, sorry.
Okay. So fy given x equal 1 of 0. So this represents your binomial distribution with the parameter n equal 1 and p equal 1 upon 13, right? So y given x equal 1. So number of successes we are saying is 0.
0.
Right? So n equals 1 and k equals 0. So what is this probability? N choose k, 1 choose 0, p to the power 0, q to the power n minus 0. So it is going to be 12 upon 13. You just have to use the formula, right? N choose k, p to the power k, 1 minus p to the power n minus k. So similarly, you try for all the other options.
I see. So this formula is for the binomial, which you said just n choose k upon, sorry, into p raised to k times.
Yeah, right.
Just one more question, please. Why is f of x equal f of x brackets 1 is 1 by 2? Is it because it can?
Okay, so fx of 1, right? So x is given to be uniform in 1, 2.
Okay, so it can be only one of the two. Is it the reason?
Yes. So if you have a random variable x that is uniformly distributed and they are discrete values, let's say 1, 2, 3. So probability of each of this values that the random variable takes is going to be equal, right?
1 by 3.
Yeah.
So that is why it is 1 by 2.
Thank you, ma'am. Thank you.
Yeah. So similarly, try for all. Yeah, all. Yeah.
But here table is given. But we can also do that if the table is given, we can sum up of all the entries, and if that is coming as one, we can choose that option. I mean, I know
Okay,
I
so
understood this.
Yeah.
formula?
So if the option is given to you, like if the table is given to you,
us, yeah.
and if you just check whether everything is summing it over 1, so
Yeah.
maybe you can get many such tables that is summing it over to 1, but the probabilities are wrong. Then what will you do in that case?
In that case, each column total should be equal. Like say one.
It should be 1 by 2.
I mean the total of that column, the entries means first column and second column, like 6 by 13 and some value. That should be, because that was the condition for a PMF. I mean joint.
That's
PMF.
a marginal one. The marginal we have.
Marginal. Yes. Sorry.
Yes. Yes. Yeah, so if the table is given to you and you can just discard few,
I mean, we can discard. Yeah.
Yeah, if you can discard, it's good enough. Yeah. But if nothing comes and if just somebody asks you like find the fxy of 1, 0, then you'll have to calculate. And sometimes table may not be very clear. Like many things can sum up to 1 by 2 and everything can sum up to 1. So it is quite difficult sometimes.
Actually, that elimination one was easy because there are 4 options. The fourth option, 3 and 4 are possible because 1 in 2 is 0. The bottom ones are 0. That is 3 and 4. And after that, one of them had power 4. So I was able to eliminate, but I didn't really get this. Why were we doing this? I didn't get it. So beating the system may be easy, but
this formula which you just told that,
so
that
this
can be used.
This is very useful. Like if you can write the joint in the form of marginal times conditional, it is very useful.
I was facing problem in that conditional only. I found out that marginal one, but I was having that problem in the conditional. So as you said, that this is the binomial.
Why is it binomial? Because you have a specific number of trials.
With replacement is there, no? So that's when I problem.
Yeah, if it was without replacement, then your probability of success will not be same, right?
It will be hypergeometric.
Yeah, right.
Like fxy is a joint probability, right? So we are writing in terms of condition probability and product of marginal probability. So it is fy given x and then fx, right?
Yeah.
The same can also be written as fx given y and
into fy. Into fy.
Right?
Fy. Yes, right.
So how to identify which form to be used?
Okay. So in this case, we already knew the distribution of x and we knew the distribution of y given x, but we don't know what is the distribution of y and we don't know what is the distribution of x given y. Right? We don't know what is the distribution of
so it will depend on the information provided, right?
Yeah, it will depend on the information provided.
And when you said binomial, because the trials were given like x was 1, 2. If you draw it 1 times, how many aces will come? 0, 1. I mean, if you do it 1 draw, as the value was known and there were only 2 values. I mean, binomial. That's why that was the reason, right?
Okay. So
I mean binomial.
Okay. So
when you identified it,
it said number of aces that you get in
extras.
In number of aces that you get in extras, right?
Yes.
And we know that x is taking the value 1, 2. It can take many values. Let's say it can take 1, 2, 3 up to let's say n. Okay. So if I put x equal 1 here, right? So what does it mean? It means you have just you took just one card and from there you want to know how many aces you have obtained, right? So what does it basically means? Like you just have one trial and out of this one trial, number of aces that you have obtained.
Yes.
Then you have second, let's say you have drawn
X
2 cards. You have 2 draws, and after first draw you have put the card you have drawn first, you have put it back into the into that deck, and again you have brought one card, right? So how many aces that you obtained in those 2 independent trials? So there the probability of success is what? So here success was defined as, how was success defined? Success was defined as getting an ace, right? So if you have a binomial, if let's say, if I'm saying X is a binomial random variable with the parameter n comma p, so what what all the criteria that it should satisfy? So all the draws, all the trials
should be random and independent.
All the trials should be independent. Okay.
And probability should be equal.
Probability of success in each trial should be same. Yeah. So in this case, number of and all the trials should be Bernoulli, right? So either you have a success or a failure. So you get one card, either you have an ace or you don't have an ace, right? So here, any draw you take, a first draw or second draw, either you will get an ace or you will not get an ace. And since it is with replacement, the probability of getting an ace is going to be same throughout. You have 4 aces and total number of cards is 52. So 4 upon 52, it will give you 1 upon 13. So probability of getting, getting an ace here is success, defined as success, and probability of success is same throughout all the trials, either first trial, second trial, third trial, all the trial, probability of getting an ace is going to be same, right?
As it is uniform.
And it is 1 upon 13, right? So all the trials are independent here. Probability of getting a success is same in all the trials. So this represents a binomial distribution, right? And the parameters of binomial distribution are n comma p. So if depending on how many draws you have, that is going to be your, if we have k draws, your n is going to be k. Yes. And p will depend on p is probability of success. Okay. So even in the previous problem or in this problem, the same concept had been used. I see. Yeah. So this is like keep this in mind. Like it is a very important property.
Yes, sir.
Yeah. Okay.
Thank you.
Yeah. Thank you. So we can check tutorial 1. Okay. Can you mute yourself?
Hello.
Yes.
Ma'am, I have some doubt. Can I ask my doubt, ma'am?
Yeah, just wait. Somebody had asked a problem statement.
Okay, ma'am.
So, yeah. I will share the screen. Yeah. So, this is week 1 tutorial 1. So the problem says you have a pack of 5 items and it contains 2 defective items, right? So you have some packet and in that packet you have 5 items and you know that in those 5 items 2 are defective. Now you are checking the items one at a time without replacement. Like what do you mean by without replacement here? So you took out first item and you checked whether the item is defective or not. Now after checking it, like you keep it aside, again you have 4 remaining items and again you pick out one item and you check whether the item is defective or not. Similarly, you do this until you find the defective items. Okay. Now your random variable x here denote the number of tests made until the first defective item is found, right? So So X denote like how many tests you have made until you found the first defective item. So either you can find the defective item on the first trial or on the second trial or on the third trial or on the fourth trial. You cannot have the first defective item on the fifth trial. Why is that? Because you have two defective items. So if the first defective item has to come, it can come either on the first trial or in the second trial or on the third or on the fourth, right? It cannot come on the fifth because you have two defective items out of 5. Now your random variable y denote the number of tests made until the second defective item is found. So similarly, how many tests can you make? You cannot have the second defective item on the first try. So you will just ignore the first test. So you can have the second defective item either on the second trial or on the third trial or on the fourth trial or on the fifth trial, right? Is this clear? I'm not sure who had asked.
Ma'am, I am Ashish. I asked it.
Yeah. Yes, Ashish.
Ma'am, this is somewhat of clear. The next question pertaining to this statement.
Can I ask a question on this itself? I'm sorry.
Yeah.
First,
right.
Let's say the first defect is on the first trial. All I need to do is 2, 3, and 4. Why do I need to do a fifth? Because if 2, 3, and 4 are normal, then fifth one is automatically defective, correct?
Okay. You're talking about 13th problem?
No, I'm just talking about the explanation that you just gave.
Okay.
Let's say I get the first defective in the first trial. Second, I get a normal. Third, I get a normal. Fourth, I get a normal. I don't need to do a fifth.
Option is not given.
That is true, but
yes.
Yeah, but we don't know whether you're going to get a normal, right?
There are only 5 items, right?
Yeah,
logically is correct, ma'am. Logically, it stands valid. Like the way we are saying that if we have not got the first defect till fourth trial, so the fifth one will give me first defect, right?
Yeah,
right.
Okay, so your point is like if we have number of tests made until the second defective item is found.
But you will have if I assume that I actually don't get defective items in 1, 2, and 3, then 4 and 5 automatically are going to be the 2 defects of the 5. So this may be sounding logical, but I'm not able to connect this with the mathematics part of it that is coming from here. So that's a question, actually.
Okay, so you are saying that x should be a range of x should be 1, 2, 3, 4.
Not even 1, 2, 3, 4. It's assuming, right? Yeah, at best 1, 2, 3, 4. At best 1, 2, 3, 4.
Yeah, it is just 1, 2, 3, 4, right?
No.
Range of x is just 1, 2, 3, 4.
Range of x is 1, 2, 3, 4.
Yeah. Because it cannot be 5.
Can I try to answer?
Yes, sure.
Yes, please.
Okay. So your question is like, if suppose the first item is found to be defective and 2, 3, 4 are not defective, obviously fifth is defective, the second defective one. So why should I have 5, right?
Yes.
Okay. So that is one of the case. It need not be the case always, right? So second defective item can be in second or third or fourth or fifth. They are only asking the range, right?
Yeah, the worst case would be representing the range. That is my
range is not the worst case. Range is telling the correct me, ma'am, if I am wrong. Range will tell you the all possible values that the random variable can take.
Yes, right.
Correct. Range is the one that tells all random variables that it can take, and if by fourth, if it is not determined, fifth is not really necessary. Is what is clear from there.
Right? It is not that always fifth cannot be taken. If 2, 3, 4 are not effective, then 5 is not. So all possible values only we are considering. So in that case, 2, 3, 4, 5 will come.
Can you just give me a minute, please? I will try this once again. Let's say I get the first defects in the first 2 tries.
Okay.
there goes, I mean, I cannot get, as ma'am just explained, I cannot get the second defect the first try.
Yes, definitely.
Yeah. So I take the first one as defective. The second one is defective. The second one comes in the second trial, second defective one.
So
After that, the positions it can carry are 2, 3, and 4, because fifth one I don't need to. If I want to find the second defective, I need to have a range between 2, 3, and 4, or I would logically need only between 2, 3, and among 4, 2, 3, and 4, because fifth one I know if 2, 3, and 4 are normal, then it goes to fifth is automatically defective. First, it can happen. Yeah.
But still, it is going to happen on the fifth trial. So the possible values that your random variable will take is 5 also.
Anyhow, you will have to do the fifth trial if
it is not that what you're taking, it is that which number will be defective, 2, 3, 4, 5. It is not that you're not going to pick because you know fifth is defective.
Okay, clear. Thanks. That makes sense. Yeah, that makes sense.
Yeah. Thank
Which
you.
trial I get the response? Yeah. Thank you.
Thank you.
Ma'am, question 14th on this statement.
14th statement. Okay. So you have to find the value of p x equal 1 comma y equals 3. So what do you understand by x equal 1 comma y equals 3? What is x equal 1?
First effective.
First effective on the first trial.
On the first trial, yeah.
Okay. And y equals 3 means?
Second effective on the third trial.
Second effective on the third trial. Can you try to solve this problem, Ashish? Now you got what is it trying to say? So whatever item you have picked, so first effective should come on the first trial and the second effective should come on the third trial. Can you try it out, Ashish?
Yes, ma'am, I'm doing it.
Yeah, so I assume you had asked about the problem statement. So do you have the problem and solution part? I think you should try it on your own first. So now you understood what is your x, what is your y, and what does this problem says. So it's just a simple probability calculation. Just try to do it on your own first. Don't look at the solution part. Try to do it on your own first, and then we can discuss. Okay, you can try it now. If you have any doubt, we can take it later.
Which problem are we referring to, madam?
Question number 14.
14. Okay.
Yeah. Okay, so next was tutorial 2, right? Tutorial 2, question number 19. It was tutorial to question number 19.
Yes, ma'am.
Okay. So here the problem says you have an urn that contains 5 black balls, 3 white balls, and 2 red balls. Now again you are choosing 3 balls without replacement, and you have 3 random variables defined there. So x is defined as number of black balls that you select, y represent number of white balls that you select, and z represent number of red balls that you select. So what is the value of x equal 1, y equals 1, z equals 1? So again, I will ask you here. So what do you understand by probability x equal 1, y equals 1, and z equal 1?
From the number of balls of that color.
One black ball, one white ball.
One black, one white,
one red ball.
Yes. So you have selected 3 balls without replacement. And what is the probability that 3 balls that you have selected, out of that 1 ball is black, 1 ball is white, and 1 ball is red? Right?
Ma'am, do we have to follow the same sequence, like first x will be selected and then y and then z, like that?
No, it's not like that. Okay, so do you want me to
Ma'am,
solve?
what does without replacement stands for this? Because my answer varied in this because I did it using without replacement part.
Okay, let's solve this problem.
Ma'am, can you
ma'am,
explain this
I want to,
without and with replacement topic, as I also got confused
I want
in
to
some
tell how
questions.
I approach this question, ma'am. Can I tell?
Okay. Wait, just give me a minute. Yes, who wanted to explain this?
Me, Sridhar.
Sridhar, yes. Please.
First, I selected, ma'am, one ball from that 5 black ball, 5C1. Can you show me the question, ma'am, once again?
Okay, so you have five balls here.
Yes, ma'am.
And you are selecting 3 balls without
No, ma'am.
replacement.
One ball I am selecting. These 5 are black, 5 black, and I am selecting one black.
Okay. Okay. We have 5. Wait.
Yes, ma'am.
This is wrong. Okay. So you have a box and you have 5 black ball, 3 white ball, and 2 red balls, and we are selecting 3 balls without replacement.
What I am doing is I am selecting one ball from black part, 5C1.
Okay.
Into 3C1.
Okay.
Into 2C1.
Okay.
Divided by 10C3.
Divided by
10C3.
Yeah.
Yeah, and I'm getting right answer.
Yeah, this is right.
Yes.
Okay, so we had let's say we had some box, and there we had 5 black ball, 3 white ball, and 2 red balls, and we are selecting just 3 balls without replacement. Okay, so somebody had asked what do we understand by, what do you mean by with replacement, without replacement, right? So if I say with replacement, let's say I have taken 3 ball with replacement. So what does it mean is, like, I pick up one ball. Let's say I pick up one ball from here. I noted down its color and I put it back there. So that is with replacement. Like, you pick one ball, then put it back, and then from that collection, you again pick another ball. But if I say without replacement, so if I pick, let's say, one ball, so if I pick one ball, let's say this color is black. So what I do is, whatever ball we have picked, we are keeping it aside. So let's say this is another box. We kept another ball here. So initially we have total of 10 balls in the bag. Now if we already have picked one ball, now remaining is 9 ball over here, right? We don't know what those 9 balls are. Now from this 9 ball, we are again picking one ball, and we are putting it back here. Okay. So once you put another ball aside, then you will be left with 8 balls, and from this 8 ball, you will pick one ball. This is what we mean by without replacement. And if we are talking about with replacement, it means we are, whatever ball we pick, we are putting it back in the bag, and then another ball we are picking from the same bunch of balls.
Ma'am, then why in this question we are, because the question is saying without replacement, then why we are not taking like 5 by 10 and 3 by 9 and multiply by 2 by 8?
Yeah, it's the same thing, right?
Answer
wait.
differs in.
Can you repeat?
Because question says without replacement, so there is no replacement is going. So suppose if we are choosing one black, so it will be 5 by 10.
Okay.
And then we are choosing one white. So from out of now 9 balls are left, it is 3 by 9.
But if you pick one ball, like how do you know there are the ball you have picked first? It's the red ball or a white ball or a black ball. Right.
But does the order matter?
The order doesn't matter.
So how does it? How like? Wait a minute.
I think the fact that we're using combination takes care of the order not mattering, and also the without replacement.
Yeah. If we are using this combination, then without replacement part will not come in picture. And this, suppose we are selecting one from black ball, then 3 white ball is already there. We can select one from this, and 2 red ball is there, so we can select one from that. And possibility of choosing 3 ball from 10 is 10c3. So we can solve it easily this way.
How do we differentiate between with and without replacement for NCR formula? The same formula will apply for both the cases. The 1098 is not reflected at all.
NCR assumes without replacement.
So how do you?
Can you repeat? Yeah.
We will use a formula here for both the cases. One is with replacement, other one is without replacement.
Suppose you are selecting 2 black ball, then one after another.
No. The problem statement is same. Okay. 5, 3, 2 blue, white, and red balls. Case 1 is without replacement, and case 2 is with replacement. And what is the solution for both the cases with the same formula?
No, it can't be the same formula.
Okay, what is the solution? Choose your own formula then.
Can I say something? Hello?
Yes, please.
Yeah, please.
When we use with replacement, then we will use in the denominator part 10c3. But when there will be without replacement, then it will be 10 cube. And the numerator part will be same. Then it is okay, I think.
No.
No,
not convinced.
Why?
You are talking about without replacement or with replacement?
This 10c3, you have understood or not? 10c3, why we are taking denominator?
That is for with replacement or without replacement?
It is without replacement. And
without
when we
replacement.
In both cases, this answer is valid. 5C1.
That means it is a 10, 9, 8 will happen. At some instance, it is 10. And once one ball is taken out, it is 9. Then it is 8.
And when
where are you showing that one in the solution? Where is the 10, 9, 8?
Hold on. I think he what he's trying to say is the numerator, you have the option of picking one of the 5 blue out of the 10 possibilities that are there.
Now, how do you know that first is blue? Why not in red?
It's a multiplication, dear. It doesn't matter which way you pick. Assuming it is the blue ball that you are getting the first time.
Okay. The order doesn't
5C1 for the B out of 10 balls that are there. That's the reason why he's saying it could be 10 cubed at the denominator, because every time the denominator is 10, 10, 10.
Yes.
Okay. 5C1 by 10, 3C1 by 10, 2C1 by 10.
This is for with replacement.
That is with the replacement is what he's saying. The number is not reducing.
Yes.
Yeah, that's okay. With replacement.
With replacement, you use this. Without replacement, you use this formula.
Without replacement, to use this formula?
Yeah, because your numbers are reducing, right? 10, 9, and 8.
Yeah, where are we showing that reduction? 10, 9, 8.
So maybe we can actually do this thing and see.
Yeah.
10C3, when we say it is 10 factorial by 7 factorial.
But that really matters. So, now the order matters, no?
No, wait a minute. 10 factorial, 10C3 is 10 factorial by 7 factorial into 3 factorial. 7 factorial and 10 factorial, if you actually take it off, it is 10, 9, and 8. So the 3 factorial goes to the numerator.
The numerator has the 10C. I mean, the numerator has a C10, C9, and C8, is it?
Sorry?
Simply for understanding, I will say that do not see this formula. Simply take, first we take the case of with replacement. Okay. So first will be 5 by 10.
No, with replacement is over. That was told already. That's no problem. Now without replacement only we have to get it.
See, in without replacement, if you consider that 3 ball can be picked in 10C for 10C3 way, no? So the probable maximum sample size is 10C3. You got it on the denominator part.
Okay.
So
the numerator part?
You pick 3 balls.
No. The denominator part, the change in 10, 9, 8 is not reflected anywhere. No, where are we going to take that one? It's in the numerator.
Can I try?
Yes, ma'am.
Okay, so see, denominator part always says about the total number of outcomes, right? So 10, 9, 8 will come only if it is different draws. So here it says from the urn, 3 balls are chosen. So in the first go itself, we choose 3 balls. So it is only 1 draw from the urn. It is not 3 different draws from the urn. Only if it is 3 different draws from the urn without replacement, then whatever you say, 10 into 9 into 8 will come.
Yeah, without replacement, that's right.
So what I'm doing is, say for example, I have 10 balls in the urn, okay? I'm just choosing 3 balls randomly. So it is only 1 pick.
Is the total number of possibilities of choosing
that,
3 balls.
While without replacement is mentioned, it means that we are picking between 3 draws.
I'm just giving one example.
With replacement or without replacement will make sense only if it is different draws or different picks. It is only 1 pick here.
Just take an example. Suppose you have 3 balls. Okay. So how can you collect 3 balls? Take 1 ball. You say 3C one way, no?
Yes. So out of 10 balls, you're taking 3 balls. So 10C.
So the same similarly for 10 out of 10 balls, you can pick 3 balls. Is 10C3 way. That is the sample space.
Yes. Yeah, that's what I'm also telling.
Yes, exactly.
Yeah.
What you guys are telling? 3C1, 5C1, and 2C1, is it?
Yes.
That's a numerator part for with replacement case. And what is the numerator part? Now my question is where is that? Sorry, without replacement case, where is that 10, 9, 8 is reflected in the solution?
It is reflected right there. Can I try once again? I was not able to complete what I was saying. See, 10C3 is 10 into 9 into 8 divided by 3 factorial. That part is clear, right? 10C3 is 10 factorial by 7 factorial into 3 factorial. Yes?
Yes.
So 10 factorial by 7 factorial leads to 10 into 9 into 8. 10 into 9 into 8 by 3 factorial. Now take the 3 factorial to the up. That means it is the entire thing is getting multiplied by 6 times. If you are taking the combination of
I lost your trial now. So
10 into 9 into 8 by 3 factorial, is that clear?
10 into 9 into 8 by 3 factorial, okay.
That is that entire term is in the denominator. That means 3 factorial goes to the top. That is 3 factorial into 5C. No.
Can you just write it down, Subramanyam? So whatever he is saying, can you write it down? Try to understand.
5C1 into 3C1 into 2C1. Sorry?
No. What I'm asking is a simple thing, okay? And let's.
I'm trying to explain, my dear. Just
I'm not going to the solution. What I'm simply asking is, without replacement, then 1098 has to be reflected somewhere in the solution.
That is reflected.
It is, can you try to see? Just try to write it down. No?
Here I can write.
Yeah. So what is saying is, just write 5 into 3 into 2. In the denominator, you have 10C3. Okay. So he's saying like you do 10. What is 10C3? It is 10 into 9 into 8 upon 3 factorial, right? And this 3 factorial will go in the numerator part. So what you will have is, you have 5 into 3 into 2 upon 10 into 9 into 8 times 3 factorial.
Okay.
Now, the question if you are having as to what 3 factorial is, that is a combination in which you can pick the colors. It can be RGB, it can be RBG, it can be GRB or GBR.
There are 6 different possibilities.
6 different possibilities that is reflected in the 3 factorial.
3 factorial will be the arrangement with any forms you can take.
Is it clear now?
For me, it is clear.
532 and denominator with 1098 and 3 factorial takes care of any order, is it?
Yes.
Just write it down and just try to write this down.
I have written down. I'm just thinking about it. Does it really matter?
You can take a minute and just think about it.
You can arrange the red, black, and white ball in 3 factorial ways. That is what is written.
You're looking for the combinations in which you can pick, right?
Yeah.
So the combinations can be RGB, it can be RBG, it can be GRB, it can be any of these possible combinations.
Yeah, that's a 3 factorial. That's okay.
Yes, that's a 3 factorial. Clear?
Then the 532. Yeah. Yes, I'm confused. Thank you.
Great.
Yeah. Thank you so much for this discussion. Yeah.
Ma'am?
Yes, who is there?
The question doesn't say anywhere that all the 3 balls are picked in one attempt. Then what is the significance of that word without replacement? Sorry, just a second. Yes, without replacement. Without replacement. 3 balls are chosen without replacement, right?
Yeah.
So it means they have picked in 3 attempts, not in 1 attempt, right?
It is like 3 balls have been just picked.
Without replacement. When the
without replacement.
When the word without replacement comes, it means that we are taking one at a time. First attempt 1 ball, second attempt 1 ball, third attempt 1 ball, right? I'm just trying to understand where my understanding is going on.
Yeah.
I think someone is giving the explanation that all the 3 balls have been picked up in 1 attempt, right? So how to interpret that by reading this line?
Okay, so if you draw first ball, okay,
right.
So first ball can be red or blue or green. So if I take, let's go there. Yeah, let's say first I'm saying I got a black ball. So let's say if the first is BWR. So you pick 1 ball and it is black. It is going to be 5/10.
Right.
I pick a second ball, it is going to be white. I'm not putting the ball back into the bag, right? It is going to be 3/9. Now I pick another ball and it comes out to be red.
Correct.
Right? So this is 2/8.
Right.
And this can happen in 3 factorial ways because you can have many different 6 different possibilities.
Yes.
So this is how it comes up. So,
Correct.
right? This is
like
3 balls you are picking without replacement.
First ball can be red or white also, right? So going by that logic, there will be 3 factorial. Yes.
Yes.
Okay. Yes.
So if you look at hypergeometric distribution kind,
right.
So what does it say? Like you are picking some, if you have n object, you are picking k object of a kind. So what you do is like if you have, let's say, n plus m object and number of objects of type n, if you have to find that probability, you just take like total choose like n choose k, and if I'm interested in objects of type n, I do n choose something, and whatever is left, so out of total, whatever is left, I do that, right? In case of hypergeometric distribution. So kind of both are same.
I'm trying to establish a linkage between what what has been told in video tutorials, sorry, in video lectures. Like it is x equal to 1, comma y equal to 1, z comma z equal to 1. It means it talks about joint probability, right?
It talks about, sorry?
Joint probability. Joint
probability, yeah.
Correct? So when we talk about joint probability, then conditional probability also comes into picture, and marginal probability also comes into picture, right?
Yes.
So how to solve this problem through that approach?
Okay, so here you have three random variables.
Correct.
You have x and y and z.
Yes.
So if you try to go through the conditional and marginal approach, it is going to be quite difficult, because you have three random variable here, x, y, and z.
Correct.
You will try to write it as f xy given z, then fx of y, and again you will multiply some term, right? So yes. So it is going to be quite difficult to solve using conditional time marginal. So sometimes it's easy to solve it just by understanding the
approach. Correct.
So even the previous problem that we have solved, like activity 1.4, so even those problems you can solve without using the conditional and marginal like this formula, and it will be quite easy, I think. Like many a case, it like the first problem that we saw in the case of Poisson and binomial, that is going to be difficult. So this this statement is useful. Like in this case, the product of marginal times the joint is useful. But in the second problem that we saw, in this case, if you solve it direct, I think it is going to be much more easier. So you can try like both ways. So in this case, it is quite complicated because you don't know the distribution of any right. So don't always try to use, like, if whenever you have to find the joint distribution of one or two or three random variable, don't always try to use the formula of conditional time the marginal.
Yes, got it, ma'am. Thank you.
I have doubt, ma'am.
Yes.
Practice assignment question number 18.
Practice assignment question number 18.
Yes, ma'am.
Okay, wait. Okay, so again, this is the same kind of problem we discussed. Okay. Can you tell me what is the problem here? It says number of people who visit a yoga academy each day is a Poisson random variable with mean 30. Suppose further that each person who visit is independently a girl with probability 0.5 or a boy with probability 0.5. So what is the joint probability that exactly 10 boys and 15 girls visit the yoga academy on any particular day?
Ma'am, what I am doing is first I am applying this Poisson random variable multiplied by, I am selecting 10 boys from 25 and
10 boys from
total there are 25. I am using this way, ma'am.
Okay.
Total there are 25 people.
Okay, 25 people, right?
Yes, and I am choosing 10 boys and using the probability 25C10 0.5 power 10 into 0.5 power 15 multiplied by that Poisson e power minus 30 upon 25 divided by 25 factorial. This is boys part, plus again I am using this Poisson into, again I am selecting 15 girls. I'm doing it right or wrong, ma'am? I'm not able to understand this properly. So you can explain.
Okay. Just give me a minute. So practice assignment solution is uploaded or not? No? Okay.
Uploaded in.
Okay. So tomorrow we'll upload it. Let's see this problem.
Can you explain me this question and how I can approach this type of question?
Yes, just give me a minute.
Ma'am, can I explain?
Who's that?
Smita.
Yeah, you can explain if you want. Yes.
We can write it as e raised to minus 30.
First, what I am doing, can you listen me, please?
Yes.
If suppose the question was asking only 10 boys.
Yes.
Not the second part, and 15 girls, then I am able to do it. E
Yes.
power minus 30, 13 to the power 25 upon 25 factorial into 25C10, 0.5, 10 into 0.5, 15. Am I right?
Yes.
Yeah. But when it is asking exactly 10 boys and 15 girls, then how I will approach this question? My question is that. Are you able to get me?
Yes.
Yeah.
But both cases we get the same answer.
Can I say something here? Perhaps we cannot actually use C as a combination because we don't know how many are coming. It is not like 15 boys are coming or 10 boys are coming. It is about how many. It's one case. It could be all 30 be the boys or all 30 be the girls also. Is that something which we should also take into consideration? Because if we take that as the case, then we cannot.
I am taking 25 people, not 10 boys or 15 girls. And the 25 people, okay. Yeah, they are coming. Then I am selecting 10 boys. Okay.
How do we know they are boys?
I don't know they are boys. They are 25 people. And okay, you are telling that all 25 can be girls.
Yes. Yeah. If that is the case, then we cannot actually have a combination there, isn't it?
Yeah.
That's what I'm trying to communicate.
Okay, then how will you approach the question if you don't know that?
Now that is a mystery for me as well, because I did not read up this part. You are way ahead of me.
Okay.
But in both cases, we get the same answer.
Both cases will get the same answers?
How I did that? First, I selected the 10 boy. Then again, I selected the 15 girls. But I'm not getting the right answer. So whether I am wrong, I don't know.
We will get the answer actually. E raised to minus 30 into 30 raised to 25 by 25 factorial into 25C15.
Okay.
0.5 raised to 15 into 0.5 raised to 10.
Yeah.
Okay, then we can write it as 25 factorial divided by 15 factorial into 10 factorial.
But the answer is e to the power minus 30, 15.
Oh, right. 25 factorial will cancel.
Okay.
Okay, we can write 0.5 raised to 25, right?
Okay.
Then 30 into 0.5 raised to 25, we can write it as, right?
Yeah.
Then 30 into 0.5 equal to 15.
Okay, fine. But still, this second part, yeah, then I'm getting the right answer, but I was not able to multiply this. I was not able to say it clearly. But I am still not able to understand this exactly 10 boys and 15 girls. If you are selecting 10 boys, then automatically there are.
Then 25 factorial girls divided by 10 factorial into 25 minus 10. Then again get the same. Probabilities are same there.
Yeah, the second part is Bernoulli. If we are selecting 10 boys from 25, if 25 there 10 are boys, then automatically 15 are girls. Are you telling that?
Yes.
Yeah, it's a binomial distribution with only two possibilities, either a boy or a girl.
Yeah.
So the fact that there are 10 girls, sorry, I'm confused, 10 boys or 10 girls automatically means the other number is boys or girls.
So what if I select 15 girls first, then 10 boys after that?
Doesn't matter. It would be the same because the probability of both are the same, 0.5.
Okay.
Taking one means you have automatically selected the remaining as the other gender.
Has ma'am left the?
No, I'm still here.
Ma'am, actually, I had asked you the question at the start, so that one doubt is remaining.
Okay. Can you tell me the problem number? So this
0.
Yeah, tell.
Week 0.28, the question number 1.
Week 0.2, question number 8.
0.2.8, question number 1.
0.2.8, question number 1. Okay.
I have one more doubt. I will ask after this.
Yeah, sure. 0.2.8.
Sorry, just wanted to know, somebody sharing the screen or it is no one is sharing the screen?
No, I'm not sharing the screen.
Okay, got it.
Okay, it is a hard problem, right?
Yes, head problem.
Okay. So the question says, the hats of 5% are identical and they get mixed up. Okay. So each person picks a hat at random. What is the probability that none of them will get their own hat?
Yes.
Okay. Does anyone want to take this question, or we can discuss it later?
Oh, I have not understood that actually.
Sorry.
I have not understood how to solve that.
Yeah. So can we take week 0 topics in the Sunday session?
Okay, ma'am, sure.
We are going to take the distribution part there. So everything will cover there.
Okay, fine.
It's Sunday, right, madam?
Yeah, it's Sunday.
From 8 to 10, same time, right?
Sorry?
From 8 to 10, same time, right?
Same timing, 8 to 10.
Ma'am, I have some conceptual doubt. May I ask?
Yeah, tell me.
Yes, sir. Ma'am, this is related to random variable. Like mathematical part is okay. I'm just trying to understand the notion of or motivation behind random variable. Say, for example, ma'am, am I audible?
Yeah, you're audible.
Yeah. Say, for example, I carry out an experiment, right? So all the possible outcomes are my sample space, right?
Okay.
And each outcome is already having a probability, right? So a numerical value has been assigned to each outcome, right? So while we define random variables, so the definition of random variable is like this, that it's a function which maps all the outcomes of
to real
all the
real
elements
number.
of sample space to a real line, to a real number, right?
Yeah, right.
So already all the outcomes are having a probability value. So what is the purpose behind creating one more variable? Do we create this to answer many different types of questions, or what is the background behind creating a random variable? Because already all the outcomes are having a numerical value associated with it.
Yeah, so what happens is like when you define a random variable, it makes quite writing things becomes easier in this case. So let's say I just take a simple example. So I am tossing my coin 3 times. So if I toss my coin 3 times, I write all the 8 possible outcomes.
Right.
So if you have to find the probability that what is the probability that okay, so I have defined my random variable. I've defined a function. What is the probability that a head occurs 2 times? So
this is not probability, this is event, no? That head
no,
occurs
this
2
is
times.
event. This is not
Yes,
probability. This
correct,
is an
correct,
event.
correct.
You have some event that let's say head occurs 2
2
times.
times, right.
So I can just pick out. So if you have 3 different, if you have 3 tosses, so
Right.
number of heads that you can have in each it can be either 0 or 1 or 2 or 3. Right. So I can just pick out the outcomes. So if I'm interested in head occurring 2 times, so it's much easier to write in this way, like number of heads that can occur in 3 trials. So I think it is not very clear. Wait.
It's visible now, it's clear.
It is clear?
Yes, it's clear.
Okay.
Madam, I have a question.
Yeah.
Perhaps you covered this already, but if we could quickly tell me how it is, it will be really helpful. I'm referring to activity 1.3, the first question.
Activity 1.3, first question.
Yeah, perhaps it won't take a lot of time also. From a well-shuffled deck of cards.
Activity 1.3. Question number
1.
1. Okay.
From a well-shuffled deck of 52 cards, 4 cards are selected at random. Let the random variable x denote the number of queens drawn, and the random variable y denote the number of kings drawn. Find f of x given y is equal to 1, 2.
Yeah. So what does it mean? It means number of, given the number of kings drawn is 1, what is the probability that number of queens drawn is 2?
Yeah. Okay.
Right. So this conditional probability, you can write it as fxy of 1, 2 divided by fy of 1. Right.
Sorry.
Fx given y, fx given y equal 1 of 2. You can write this as fxy of 2, 1 divided by fy of 1.
Fy of 1. Okay. Sorry.
So fxy of 2, 1 means number of queens drawn is 2 and number of king drawn is 1.
Yeah.
And fy of 1 is number of king drawn is 1. So can you find those 2 probabilities?
Okay. 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 So fx of 2, 1, I think it is 0.0039. That I remember from the previous activity. I need to divide it by f of y is equal to 1. That means the others can be any. Is that what?
So just one, there should be just one king, and out of those 3 cards, it can be like those 3 cards can come from all the non-king cards, right?
Yeah, all the non-king cards. Okay. All right. Thank you. Thank you very much, ma'am.
Yeah.
Yes, ma'am.
I have one doubt, ma'am. Yeah.
Yes.
In practice assignment, question number 6.
Okay.
I got this question right, but I am some different doubt, ma'am. There is a random.
That question later on.
What?
Hello, Nikita ma'am, are you there?
Yeah, tell me.
So will you cover that question later on? My discussion which was going on related to
Yeah,
Okay, ma'am.
It was not very clear. I will come up with a good example to illustrate it. Is it fine?
Okay, no
for
problem.
the Sunday session?
No problem, ma'am.
Yeah,
no problem.
all
Just a follow-up question to that, ma'am.
Yeah.
Like we say that each event is a subset of sample space, right?
Each event is a subset of sample space, right?
Correct. So say for example, there are 6 elements in my sample space. So total number of subset will be 2 to the power 6. Correct.
2 to the power 6, right?
As per our set theory. So
yeah, right.
So can I say that the sum of probability of all the events will be 1 here also? Because for sample space we say that if all the outcomes are disjoint, right?
Yes.
Then sum of all the probabilities will be equal to 1. So whether the same logic applies for all the events also, because number of events will be much more. Say for example, if I take the example of cards, so there are 52 cards, right?
Yeah.
And if I take the probability of finding, taking it out 1 card at a time, so there will be total 52 elements in my sample space, right? So total number of events will be 2 to the power 52. It will be a very large quantity.
Yeah,
right?
sum of all the event is not actually going to be equal to 1.
Then it may be more than 1 also.
Ma'am, can I say that? Because normally what happens is for all disjoint events, the sum of probability will be 1. But in the case of all events, it will only be independent events and not necessarily disjoint.
No, so that is my question.
They need not be necessarily disjoint, but if you're talking about probability.
My question is, let me define my question properly. I'm saying that each event is a subset of sample space, right?
Right.
So say for example, there are 52 elements in my sample space. My sample space consists 52 elements. So total number of events will be 2 to the power 52, correct?
Okay, yeah.
So sum of probability of all the events, whether it will also equal to 1 or it may cross 1 also. Summation of probability of all the events.
See, we are talking about probability here. So of course, it is not going to be greater than 1.
Probability of any event should not be greater than 1.
Any event should not be greater than 1.
Probability of a single event should not be greater than 1.
Yeah,
but probability of summation of probability of all the events, I'm asking, all the events, 2 to the power 52. Or let us take a simple example, 2 to the power 6.
Let's take some example. Let's say I'm throwing a die. Let's tossing a coin.
No, let us take we are throwing 2 dice. So total number of elements will be 36, right? Total number of elements in the sample space will be 36.
Let's take the dice example. So let's say I have two coins. Let's say we have 2 coins. So if we throw the 2 coins, it is going to be HH, HT, TH, and TT, right? So
total number of events will be 2 to the power 4.
2 to the power 4.
Correct. So 16.
So let's take some event. Let's say HH is one event. And
first of all, it will be cumbersome to write down all the events. 16 events.
So let's define a random variable here first. So number of heads.
How random variables will help, man? I'm asking all the events. There will be 16 events.
Yeah. So what?
Ma'am,
like
I
what
think
I'm
that
defining.
all the events, the probability of all the events will not be just 1, obviously, because not all the events will be disjoint from each other. And since
that is right.
So that's what my doubt is.
One can only happen if all the events are disjoint events.
Whether the summation can be more than 1, that's my question. Whether the summation can be more
yes,
than 1.
but then it won't be a probability because probabilities are...
No, probability of a single event should always be less than equal to 1. Probability of a single event should always be less than equal to 1. I am asking the summation of probability of all the events. That's my question. Say, for example, this kind of true-false question came, then what will be your answer? It's a conceptual question. It's a
The
conceptual doubt. It's a
probability
conceptual doubt.
Look, the probability of all the event in a sample space will be equal to 1, not greater than 1. If you are talking about all the possible event in the sample space, then the summation of all the probability of all the events will be equal to 1.
Not if it is not disjoint. Only if it is disjoint, it will be equal to 1.
If all the events are disjoint, like in sample space, all the events are disjoint. That's the reason why it comes to 1.
Yeah.
But when all the events, when I am telling you that here there are total 16 events, and if I try to write down all the events, and if I try to find the probability of all the events, then what will be their summation? Because it will be greater than equal to 1 or less than equal to 1.
No, regardless of your thing, na, probability summation of all the events, it will be 1 only. It cannot be greater than 1. Regardless, you add all the events. Let us say if you define 1 event or 10 events or 15 events, so addition of all the events, the probability will become only 1. It cannot be greater than 1.
So are we saying that all the events are always disjoint events? All the events are always disjoint events?
Because it could be disjoint or joint event also, but probability.
No. Actually, see what happens is if you take the coins case also, right?
Yes.
And if you have a 3-coin sort of throw, then you can easily say when all the events where, let's say, for example, head is in the first throw, right?
So in
head
that
is
case,
it is only not a disjoint event.
No, in that case, what do you say? Like 1/3, 1/3, and 1/3. So addition of all these 3, it becomes only 1. So that is in the first lecture, as I think the professor has told very clearly.
For the disjoint event.
No,
and
no,
what Vijay is saying is absolutely right. I am also trying to understand from that direction only, that if my events are not disjoint, and here we are total number of events are 16. But say for example, let us take the example
disjoint events. No, disjoint events comes into picture when you write A complement intersection B complement. In that case, it becomes a multiplication of that. So disjoint only becomes applicable or becomes viable when the intersection of the both events is equal to the multiplication of that intersection. That is only the case when you consider your disjoint events. But when you are going to find out the probability of any such events, probability of addition of all the events is equal to 1 only. Disjoint, if you don't get confused with the disjoint term. Disjoint term comes only into picture when you're applying a formula. For example, when you're applying the learning the Bayes theorem, there is a probability of A given B. In that case, there is a clear cut formula. But when it becomes a disjoint events, that time you just multiply that intersection. Let us say complement.
I'm sorry, I really beg to disagree, because see, when you are talking of a sample space, you can generate any kind of events from the sample space, right? You can define whatever you want and make that an event, as long as
and mathematically the number of events will be 2 to the power n.
And the number of events you can generate is 2 raised to n.
Yeah, that is clear. You can define 10 events or 15 events also. But if you find
you can
not any events. There is a formula, number of elements in the sample space. So 2 to the power number of elements.
You can only define 2 raised to n types of events. I can say, for example, 1, 2, 3, 4, 5, 6 is an event. 1, 2, 3, 4, 5 is an event. 1, 2 is an event. 1 is an event. Null space is an event. So I can generate any number of events.
Can we just mute it here? Can we take this question on discourse? It will be good to discuss there. Okay.
Yes, ma'am. I will put
just put this question on discourse. We will discuss
but
there.
let us expect. Let us assume that we'll get the right answer. We should not get in multiple directions.
Yeah. So just put this question on discourse.
At the beginning of the session, I was trying.
Can we move on the next question, ma'am, please?
Yeah. So what I'm trying to say, just this problem, just put it on discourse and let people give their opinion there. Okay. So it's better. I will also go and check the post.
I have a doubt in practice assignment 1.
Okay, so this is the last problem that I'm taking. It's already 10:24. Okay. Practice assignment question number 6, right?
Yes, ma'am. Actually, I don't have a doubt in this question number 6. I got it right, but I want to know Z is a random variable. Okay.
Z is a random variable, right?
Yes, ma'am. If I am asked find the probability of Z of 18 given Y is equal to 2.
Z equals 18 given Y equals 2.
Yes, ma'am. Then
okay. I mean the seventh problem. Okay.
Will it be equal to fxy 3,2? I am asking that.
Fxy 3,2.
Because for z is equal to 18, we need to put x is equal to 3 and y is equal to 2.
So you know that y equals 2, right?
Yes,
and
yes,
y equals 2 and you want z to be 18.
18.
So
yes.
x should be definitely 3, right?
Yes, ma'am. Yes, ma'am.
Yeah,
I recall
so
from the previous term that
yes.
if we change the random variable function, but the probability remains the same.
So you will get 4k, is it?
Yes, ma'am.
So what is the value of k that you're getting here?
Not 4. No, ma'am, I'm asking whether I'm going in the right direction. I'm asking the probability of.
This can be done.
So in this way, I can find all the possibilities of Z, random variable Z probability given y equal to 2, y equal to 1, y equal to 3.
Just hold on. Yeah, tell me again.
In this way, I can find the probability of Z given y.
Probability of Z given y.
Yeah.
Yeah.
In the range of Z. And the probability will be same as fxy x comma y.
Fxy x comma y. Yeah, but this will work only if your x is going to be taking that value. Like in this case, it was
yes, ma'am.
Easy because x was taking the value 1, 2, 3 and y was taking the value 1, 2, 3. So given y equals 2, we can say x is taking the value 3.
Okay. And when will be the case? I will not be able to.
So z equals 18 if you solve it. So it is going to be fz of y 18 comma 2 by fy of 2. So okay, so if something like this happens, right? So if you are going to write it, if you are going to write it, you are going to write fz of y of 18 comma 2, right? So z is going to be 18 only in the case when x is 3 because y is 2 is given. So we don't have any issue. But if z is something else, let's say z was 17 or 16, so in that case it is going to be taking the value 0.
Z can't take the value 16 and
yeah, that's what. So it is going to be 0. The probability is going to be 0 because we know that z is defined as x square y, right? And if y is given to be 2, it means x square should be 8. But there is no such x for which your x square is going to take the value 8. So this probability is going to be 0.
Okay.
Okay.
Okay. I got it. Thank you, ma'am.
Yeah.
Okay. Thank you, ma'am.
Thank you very much, madam.
Yeah. Thank you. So.
Good night.
We can conclude, I guess. Thank you very much. Have a nice evening.
Yeah.
Whatever is left of it.
Yeah. So whatever topics had been left, so we'll discuss it on Sunday. Or if there is any open problem, we can put it on Discourse. We can discuss there also. Yeah. So yeah. Good night, all of you. So if you haven't gone through week 1, you can go through it. And next we'll meet on Sunday. Okay.
Thank you. Good night.
Yeah, good
Thank you,
night.
ma'am. Thank you, ma'am. Thank you very much.
Yeah, thank you.